Hello guys. So we'll move to the next question on projectile motion. So this time two objects thrown at two different height from two different height. The first object is thrown from a height of 5 meter with a speed 6 meter per second, and the second object is thrown from a height of 10 meters with the same speed 6 meter per second. Our task is what is the distance will separate the two objects when both land on the ground. So you need to find, so this is the trajectory of the first ball and this is the second, the trajectory of the second ball. You need to find this delta r. So how do you do this? So what I'm going to do is I'm going to use S equal to ut plus half gt squared for the first ball, okay, for the complete motion, meaning to reach the ground. The displacement is for the first ball when the first ball reaches the ground is 5 meters. The initial speed is 0 because you actually throw the ball in the horizontal direction with 6 meter per second. So there is no vertical component. So this part will be 0. This would be 0 plus half acceleration due to gravity is 10 into t squared. So if you simplify this, you will get t equal to plus or minus 1. So minus 1 can be omitted. Therefore t is equal to 1 is the time taken for the first object to reach the ground. Now I want to find the horizontal range. What is the distance, the distance traveled by the object in the horizontal direction? So I'll use s equal to ut plus half gt squared, and we know there is no horizontal acceleration, so this part would be 0. So we'll be having just s equal to ut. So I'll say the distance traveled by the object is r1. So r1 is equal to, the velocity is 6 into 1. Therefore the first object is actually traveling 6 meters in the horizontal direction, r1. So we found this one. So similarly I'll use the same logic to find for the second object. So the ball at 10 meters now, I'll use s equal to ut plus half gt squared. So to reach the ground, the object should travel 10 meters now downward. So the displacement is now downward 10 meters. The initial speed is again 0 because you throw the ball in the horizontal direction, so there is no vertical component. So I can say this would be 0 plus half into 10 into t squared. So if you simplify, you will get t squared is equal to 2. Therefore t is equal to square root of 2. Square root of 2 mean 1.414. So this is the time taken for the second ball to reach the ground. So now let's check what is the horizontal range. So how do you find it? I'll use s equal to ut plus half gt squared in the horizontal direction. So for the second ball, the horizontal displacement, let's say r2. So r2 is equal to, we throw the ball with the same speed 6 into time, here we found 1.41. So if you multiply these two, you get 8.46 meters. So now we found both range. So if you know these two ranges, simply you can say the distance between them is delta r, which is equal to 8.46 minus 6 meters, which is equal to 2.46 meters. I hope you got the idea. So we'll move to the next question. So this is our next question. Okay, so the next question is like this. You throw a stone with 10 meter per second with an angle 40 degree with respect to the horizontal axis. You need to find the direction of the velocity vector after 1 second. Okay, so you need to find what is the velocity, the direction of the velocity vector after 1 second. So how do you find this? The first step is I'm going to divide these vectors into two components, two perpendicular components. We know how to divide this. First, if you divide a vector towards the angle, we said this part would be v cos. Okay, so you see this is 10, so 10 cos 40 is our horizontal component and the vertical component is 10 sin 40. So if you simplify this horizontal and the vertical components, you will get horizontal as 7.66 meter per second and the vertical 6.42 meter per second. So my task is to find the direction of the velocity vector after 1 second. So let's say after 1 second the position of the stone or the ball is somewhere here. Remember this component, the horizontal component doesn't change because there is no force or the acceleration in the horizontal direction, because we said in the horizontal direction acceleration due to gravity is 0. So this component doesn't change. So whatever the position you take, this component doesn't change. So you need to find what is the vertical component. So what I'm going to do is, in the vertical direction I'll use v equal to u plus gt. So v, the initial speed, you throw the ball with 6.42 meter per second. So this is our u, minus, because we throw the ball upward but the gravity is downwards, hence we put here minus sign, 10 into t. T is after 1 second. So if you simplify this, you will find v is equal to minus 3.58 meter per second. So meaning what? We put the equation in the upward direction but we got the answer in negative. So meaning after 1 second the velocity vector is downward actually. Okay, so this is our 3.58. So from here you can see now, so we agreed this horizontal component doesn't change, which is 7.66 meter per second, and the vertical component just now we found, that is downward 3.58 meter per second. The question is what? You need to find the direction of the velocity vector, okay, after 1 second. So you see, if you know two vectors you can find the resultant, but this is not our question. Our question is you need to find the direction. So let me say this angle is theta, okay, with respect to the vertical axis, the resultant velocity vector makes an angle theta. So from here I can say tan theta is equal to opposite side would be exactly this one, 7.66, divided by this adjacent side, this would be 3.58. So if you divide from here, you get tan value. From here simply you can find the tan inverse of this value. Therefore theta would be approximately 65 degrees. So meaning after 1 second the velocity of the ball will make an angle 65 with respect to the vertical axis. I hope you got the idea. Okay, thank you for watching.